Okay, this is the first lesson on section 1.3, dealing with changing bases, so solving exponential equations without needing logs, and with some basic graphing by hand of exponential equations. So let's do this real quick. First of all, to rewrite 1/16 to the 2x in base 2, I would ignore the fact that this is a fraction and just focus on 2 to what power is 16. Of course, the answer is 4. 2 to the 4th power is 16. So to get a 1/16, we need 2 to the negative 4th power. Okay, so 2 to the negative 4th power is 1/16. That just replaces the 1/16. So we take this to the 2x. Well, to combine power to a power, we multiply. This becomes 2 to the negative 8x. Next, kind of along those same lines right here, we think, well, 3 to what power is 27? That's the third. 3 squared is 9. 3 to the third is 27. So to get that fraction, we just need to make it a negative 3. 1 over 27. So in this case, x is equal to negative 3. Going up top, 3 to the x equals 9 squared. Well, again, we want to rewrite our bases to be the same. We usually go to the lowest base, so I'm going to rewrite 9 as 3 squared. So that replaces the 9. Of course, we still have a squared there because it was 9 squared. So we get 3 to the x equals 3 squared squared. And again, a power to a power. We multiply, becomes 3 to the 4th. So the original question becomes 3 to the x equals x to the 4. 3 to the x equals 3 to the 4th. So x must be 4. In this next question, you may need to use the calculator a little bit. 4 to the 3rd is 64. So you start typing them in. 4 to the 4th, figure out what that is. But 4 to the 5th is 1024. Well, 4 to the 5th is 1024. That must mean that 2x is equal to 5. So x is 5/2. Last question on this slide, 25 to the 3x in base 5. Well, I can rewrite 25 as 5 squared. Put that to the 3x power. And one more time, power to a power, we multiply. So this becomes 5 to the 6x. Real quick, talking about some exponential, some things about the exponential function. If you can think about just a real quick sketch of what an exponential function looks like. It looks something like that. Or if it was decaying, of course, it could go the other way. It could come down like that as well. But essentially, the domain is all real numbers. Everything will work, negative infinity to infinity. But the range, it never goes to 0. It's from 0 to infinity. Okay, 0 will never be touched because we can make the numbers really small. 2 to the negative 2nd is 1/4. 2 to the negative 3rd is 1/8. 2 to the negative 4th is 1/16. But we'll never get to 0. Well, because of that, there are no x-intercepts. And the y-intercept up here is always 1. The x-axis, we've kind of stated this a couple different ways here. The fact that it never touches 0, that there are no x-intercepts, that makes the x-axis a horizontal asymptote. To get the function to increase, of course, we need the x to be greater than 0. Okay, for example, 2 to the x looks like that. If the x is less than 0, if it's 2 to the negative x, then it looks like that. The other way, though, to do it is focus on A. If A is greater than 0, it'll increase, or A is greater than 1, it will increase. And if A is less than 1, it will decrease because you'll continuously be multiplying by numbers smaller than 1. To graph it, I would always use 2 points. I would always start with the intercept 0, 1, and then I would plug in 1, and of course A to the first is A. That would give me my shape. Always use those 2 points. So let's try that real quick. I'm going to graph this in stages. Okay? We're going to start by just graphing 2 to the x power. Well, 2 to the x power goes through 0, 1, and 1, 2. So it kind of comes along like that. Okay, now let's transition because this was to the negative x power. So that's going to reflect it. So now it's going to look like that. And again, this is just a real general sketch. Next, let's do the multiplying it by 3. Of course, that'll just stretch it. So instead of 0, 1, it'll go through 0, 3. Instead of negative 1, 2, it'll go through negative 1, 6. Just stretching it out. That. And finally, the last piece of information shifts it down 3 units. So do that. Of course, now I'm going to just kind of put some dots here for what this new asymptote is. It's going to look something like that. So this black, it's going to get a little messy maybe with but that will be our final answer of the basic idea of what this graph looks like.